All right, let's get started today with this problem in front of you here. I want you to just read it and take a minute to work through it, do what you can with it, and then come on back and listen to the solution. Just remember, I'm looking for a parabola. I gave you the vertex, I gave you a coordinate. Use the hint here, figure out what parameters you have and which ones you need, and good luck. Pause for a minute and try it. All right, so the first thing you should be thinking about is when you know the vertex, you know how the shifting has occurred. So if the vertex is at 4, -5, then that means h was 4 and k was -5. So when you go to fill in the formula, you can start, you need AH and K as parameters, so you can start filling in some of these parts. So this is going to be my final answer here, this light blue. We'll get to that in a minute. Did you get it right? Maybe you did. So the 4 and the 5 went, the 4 and the -5 went in, right? The 4 went after the minus sign, and the -5 went on the end. And remember that an H shift is always opposite, so we have that to begin with. If it passes through 6 and 10, then that's an XY coordinate, and that would go where the X and the Y are. So all that's left to solve for is that stretch factor. And so if you just work around it, you have 2 squared, you have -5. So the 5 gets added to the right, and the 4 comes from squaring the 2. So you don't want to do all this part together. This 6 minus 4 squared would be the coefficient on A. And that's important to note because that's a trouble spot that some people get stuck on. The -5 then gets added to the left, and we divide and we get 15/4. Or you could have written it as 3.75 because that decimal terminates. So if we're ever trying to write an equation from a vertex and a point, all we need to do is substitute h and k from the vertex, substitute x and y from the point, and solve for A. All right, so there's a problem to get us started. So I want to just go back real quickly to the completing the square concept when we have a coefficient in front. So I just got a couple of examples here for you to write down and try. Starting with 2x squared plus 5x minus 7. This may look familiar to you, but to remind you, when we do these with a coefficient in front, we must start by dividing out that coefficient. So your first step should be to rewrite the equation with the 2 divided out of each term. You can't complete the square unless you have a single x squared. So we need to do that step first. Use brackets here because we're also going to add parentheses on the next step. So we start with brackets after taking out the 2. Then within the parentheses, you're looking at that b value and we're cutting it in half to get h. So h is b over 2. Take the 2.5, divide it by 2. Then what you want to do is square that number, right? That b over 2 gets squared and compared to -7. So when you square the 1.25, you need 1.5625. But what we have is -3.5, not -7. -7 was in the original problem. We're comparing it to this one. And so how far short are we? We're short by 10.125 units. No, we're short by 5.0625 units. And then the last step is to redistribute that 2, so it attaches to the parentheses as a stretch factor, and then it comes out here for the k as well. And so we end up with -10.125 as our vertical shift. So again, divide out the coefficient, set up a set of brackets, complete the square on the brackets, and re-multiply the stretch factor back in. All right, another one. If you want to pause and try this one, we'll come back and discuss. All right, so the first step, as was in the previous one, we're going to divide by 6. And notice on the end I wrote 5/6. If I didn't write 5/6, I would have had a rounded decimal, and wherever I round, I've created an inaccuracy. So I'd rather keep it as a fraction and work off of the fraction instead. So my next step is to divide the 3 in half, make it 3 halves. Again, not 1.5 because I'm dealing with fractions here. So I'd rather have fractions throughout. Okay, so I have 3 halves. So where did the 17 halves come from? What I'm doing now is I'm squaring the 3 halves, and I get 9/4. That's what I need. But what I have is 5/6. And so what I want to do is compare the 9/4 to the 5/6. So I change them both into 12ths. I need 9/4, I have 5/6. So to compare them, I made them both the same denominator. So what I needed was more than what I had by 17/12. That was the difference. and so I'm short by 17/12. There's my shortage. Okay, so the next thing I do after I've written down my shortage is I redistribute the 6 back in, which is attaching to the parentheses and multiplying by the fraction. And that's 6 over 1 times 17 over 12, which would be 17 over 2. The 6 and the 12 would reduce to 2. Or you could then take that answer and convert it to decimal form if you'd rather. So if you were graphing it, maybe it would be easier to see it as decimals. But during the calculation stage, if you ever get a decimal that does not terminate, you've got to keep it as a fraction all the way through. And then you can get your final result from that. And then the last thing I wanted to do was just backtrack to page 30. The last problem on page 30, when it was assigned, was a completing the square problem that had a coefficient you hadn't worked with that yet. So just to recap how that's done, it's the same thing as what we just went through. Divide out the 4, you get a -1. Divide that by 2, you get 1/2, not 0.5. Let's keep it as a fraction. Then what we're doing is squaring the 1/4. We need squaring the 1/2, we get 1/4. So that's what we need. What we have is -2, and so we're short. Now -2 is -8/4, so we're short by 2 1/4, quite a ways. So that's 9/4 that we're short by. Distribute the 4 back in, and it attaches to the parentheses and multiplies by the fraction to give us -9. All right, so that recaps the old stuff. Now we're going to get into a new topic. So I need you on page 31, and we'll just fill in what you have here. So the graphing equation, which we should be very familiar with by now. In order to use that equation for modeling, what we're going to try to do is figure out what the parameters are, the A, the H, and the K. So in this particular problem, we've got a jackrabbit jumping over a 3-foot-high fence. Now, to model this, I set up an X and a Y axis, and I set it up to intersect with an origin where the rabbit jumped from. That just seemed easier to me. So I have 0, 0 at the jump point. I have 8, 0 at the landing point because the problem told me that the rabbit must jump 4 feet from the fence. So that must mean that it's an 8-foot distance total. The fence is also 3 foot high, so that'll be the maximum height that the rabbit gets to. So that information is enough to establish a vertex, because the middle of the 8-foot jump would be 4 feet, and the height would be 3 feet according to the height of the fence. We've got all that labeled. We know that the path makes a parabola, so I've got my axes set up at 0, 0. I always want to have the object start its flight at 0, 0. And that's not something, so it will work mathematically if you put the axis anywhere you want. It's just that it's much easier if you have a 0, 0 coordinate. So my recommendation here that I hope you take for each time you do one of these is to put the origin of the jump at 0, 0. All right, and then you make a point at the farthest distance that it traveled. So the landing point. You have to find the vertex, and since there's a line of symmetry, it's just going to be in the middle of those x-intercepts. So if you have a start point at 0 and a landing point at 8, then the vertex will be halfway. You find the average of those points, that's your h value. Then the problem's going to give you a maximum height, and that'll be your k value. So these are all the steps. Okay, so we've got the vertex plotted on the graph. It'll make a parabola. We want to substitute everything we know, which will be the h and k from the vertex, the x and y from the landing point, or the starting point, either one, and we solve for a. And finally, we just insert the parameters. So those are the directions. You can take a second to pause and copy those down if you need to, and then we'll go through how to set up the problem. All right, so in black here, I've set up the beginning of it. I put the vertex in first. Then I chose 0, 0 as my x and y. However, the problem will work exactly the same way if you chose 8 and 0. So either coordinate is fine on the x-axis. I need to take care of this a coefficient first. So -4 squared is positive 16. Remember, squaring a negative equals a positive. And I did not combine that with the 3. That's important. Be careful about that. The 3 gets subtracted to the left, and now I can divide by 16. So this is exactly the same as the bell work. We're just trying to figure out what the parameters of the equation are. I get -3/16, and I have my equation modeled. From here, if I was then asked a question about what height would it be at a horizontal distance of 2, I could then plug in a 2 and figure that out. Or I could say, when did it reach a height of 1.5 feet? Given that information, I could use my modeling equation to solve it. But the way you get the modeling equation is to locate the vertex, pick a point on the x-axis, insert all of that, and solve for A. All right, so if all those notes are down, you can move on to page 32. And your task for the class period is to complete the work on page 32. I'm going to continue this video in just a second. Oops, I want this point down here. I'm going to continue this video in just a second, so you'll be able to view the solutions, but you need to stop here and do page 32, and then come back here to check that you did it right. The homework will be page 33. That'll be checked in class. And there's a Delta Math assignment that you may or may not have finished when assigned, so that needs to get done as well. So the problems on page 32, use this setup with the graph and the parabola starting at 0, 0 with a vertex and a landing point. All right, so pause here and then come back to check. All right, so on page 32, we're starting with the soccer ball, horizontal distance of 150. So I have it starting at 0, landing at 150. That means that halfway would have been 75. And it said that it reached a height of 100. So that's the other part of my vertex, is the maximum height. So I go to my graphing form equation, I insert my vertex information, I insert my starting point, and then I start working on the calculations. So 75 squared is 5625, that attaches to A. 100 then gets subtracted over, we divide by 5625. I've reduced it here to 4 over 225 just by dividing both parts by 25, and that becomes my coefficient and my stretch factor. So now, to answer the second question, horizontal distance of 120 feet away, that's my x because it's horizontal. So I put 120 in for x, enter all of that into the calculator at once, and it'll give me an answer of 64. Example 3, I have a vertex given to me, so I know what h and k are right away. This one does not require a graph or a sketch, it just gives me all the information straight out at the outset here. X and y, because it's passing through this point. That's not an intercept, it doesn't matter. Any point on the curve will work. So just be careful that you put those in the right spots. This is 6, when I square it's 36. So that's my A coefficient, adding the 7 gives me 90, and dividing gives me 2.5. So my final graphing answer looks like this with an X and Y in it. And example 4, this will be the final one. So skateboard park, U-dip, cement structure, cross-sectional view is a parabola, so there's my cross-section, dipping 15 feet below the ground. Now it says that the widest part is 40 feet across, so if it's starting at 0 and ending at 40, this is going underground because it's a dip. So I have negative 15 as my minimum height. The 20 comes from halfway between 0 and 40. So again, my vertex gets plugged in, negative 20, or 20 and negative 15. 20 goes after the minus, negative 15. And I used 0, 0 here, but 40, 0 would have worked too. 0 minus 20 gets squared, becomes 400. 15 gets added to the left. Divide by 400 and reduce. So 3/80ths becomes my stretch factor. Notice this is the first time we've had a positive coefficient, and that's because this parabola is opening upward as opposed to the others that typically open downward. Do not force a negative. If the parabola is supposed to open downward, it will. The A calculation will come out negative if it's supposed to. So never put a negative A into the problem. That's just going to work out if it's supposed to. And then when you're 10 feet across meaning horizontal, x is 10, put a 10 in and solve it out. You should have negative 11.25. All right, so again, your assignment is page 33, and also finish up any delta math.